Hello guys, this is another cold fusion video. Video may be a little boring, but I'm going to make it anyway. This was my recent cold fusion experiment. I don't, focus. And I had a pretty good result. And I had a pretty good result. You can see there's a 3 electrode, which is very unaware because most cold fusion use just 2 electrode, just 220 volts. That's it. That's how they make cold fusion in just normal way to do it. But here I use a different method. You can see it's 1, 2, 3, 3 electrode. This means I'm using another voltage here, 12 volt. This means it's a little awkward, but this 12 volt. Okay, I'll explain it simple to you guys. So when you create electrolysis, it create hydrogen, right? But in the water, because of high voltage, 220 volt, the plasma ignite the hydrogen. Okay. So what about 12 volt? But what if we create a hydrogen using a 12 volt? Okay, so it is more efficient to create a hydrogen with lower voltage. Imagine you use a 12 volt, 5 amp of hydrogen against 220 volts against 5 amps. That's 1 kilowatts of power, right? So this is somewhere around 52 watts of power. You can see the clear difference. The hydrogen amount is roughly the same. Would you believe it? It's roughly the same. 52 watts and we got 1000 watts. So because if we are using a 220 volt electrolysis, normally you have to use many different plates. I mean, very large plate, a stack plate like this. But this cold fusions, when you are doing electrolysis, we're using a very tiny one electrode. We're using 1 electrode and start to burn a little bit, a tiny bit, a bit. So that's very weird thing about cold fusion. So here I'm using only a 12 volts and the 220 volts. We mix the voltage. 1 electrical wire goes to this here. So you might think all those electrical wire will be fucked up, right? Well, we have a blocking diode here. That's what blocking diode does. The blocking diode does not, current cannot go into other directions. It only goes into one path. So that's what's great about the blocking diode. So we solve that problem. Now this is for a home heating. This device is for home heating, for a commercial device. I've been testing a lot, and this is probably the best way to shape the circle, because now when hydrogen gas is produced, even I would say some of the 80% of hydrogen gas is burned. 20% of the gas stills inside the chamber, and eventually, if those gas will build up, the chamber will be explode. So we have to burn all those 20% of hydrogen gas. To do that, all these hydrogen gas will be in this circle, in this direction, and come back to this electrode. These gases will come back to the electrode and burn up again. And this process goes over again. Okay, so that will also increase the efficiency of cold fusion because we're burning all the hydrogen gas. And this electrode, this is just a stainless steel bar. So these stainless steel pipe will release a heat, and this is a fresh water. And what do you do with this fresh water? It's probably very hot water or warm water. You can take a shower. So this is the home heating device for cold fusion. Home heating cold fusion. Cold fusion. So that's it. The key is to use 12 volts and 220 volts. We reduced. It would be a good idea to use resistor, or I'm sorry, very little amount of. You don't want too much 220 volts amperage going in. You might want to use a resistor, but water is already resistor enough, so you want to use very little amount of electrolyte, and let the 12 volt do the hydrogen productions. Oh yeah, and you also need a plastic basket here, right here, because in case, just imagine, because anything could happen. You know, this electrode, if it fail or burn or something, those kind of stuff, it will actually fall down, and the person could be electrocuted. So you might want a plastic bracket. Is that what you call a bracket? A holder. So if something happens, this plastic will hold the electrical wires. So this is specifically for a commercial device for cold fusion. I've been thinking about a lot, and you probably need $1 million to build this one, or even more. Thank you for watching the video. Bye bye.